Hi, I'm Souradeep Dutta. I'm an assistant professor in the Department of Electrical and Computer Engineering. My research is on safe AI, trustworthy AI for robotics and medical applications. More specifically, these days I'm interested in the idea of memory-guided models and using that to improve how things learn and how inference is made. So ECE departments actually give you a much more broader range of skills than pretty much any other department in its intellectual neighborhood, right? So it gives you skills on how do you handle hardware, so sensing and acting in the real world. And it also gives you some perspective on how computing works, so how the computing of mathematics works. So if you think about the actual problems we are facing in the real world right now, things like self-driving cars, things like physical intelligence, things like automating manufacturing and problems like that, ECE kind of gives you the skills which really help you make an impact in the real world. So it lets you work on algorithms, the learning algorithms, the inference algorithms, and also gives you skills to make sure that those actions that you compute about actually have an impact in the real world, which are useful. So I think that's where ECE comes in, which gives you the skills of both hardware and software, and is probably one of the most useful skills that you can have in today's world. Okay, the favorite place on campus, which I just realized, is called the Rose Garden, and it's right down the engineering street, I would say, and it overlooks the mountains and the oceans. I think that's one of the best spots I've seen till now on pretty much any campus that I've been to. The favorite thing to do would be to be outside, right? So, and I think Vancouver is one of the best places to be among the mountains, and I think anything to do with the mountains is great. So skiing, hiking, snowshoeing, anything outside and in the mountains is great. So I've started to take interest in a little bit of jet skiing as well, but I think Vancouver waters are a little too cold for that. But other than that, I think anything to do with the mountains, yeah. So in autonomous systems, what you're really trying to do is mimic your own thinking patterns into a machine, right? And there's something very deep about it, which is when you're actually discovering things about how to act in the real world, you're discovering how the human mind works at a more functional level. And doing so can actually create much more impactful solutions down the line for technology and human beings as a society. So I think that's so clearly thinking about problems on how to solve a specific problem with manufacturing or medical applications can discover really useful solutions for the future. Now, clearly in 2024, AI is the right thing to be working on, but it's sort of dusty, right? So we need to be very careful in what are the problems you work on and what is the end effect of that problem, rather than just trying to use it as a tool on anything that you see. So we also have to be a little careful in how we use this moving forward. But yeah, in general, I think this is clearly the right thing to be working on and having an impact on the world. So the main way I got interested in this was I realized I was always good at some degree of math. I was good with computers and I was good at coming up with new ideas. And the broader impact was I wanted to leave behind a legacy when I'm old. So right now it turned out that trying to make machines mimic how humans think was a great idea to work on, and that's how I got interested. And yeah, that's why I'm here. And I think in generally it's way more useful for people to be capitalizing on what they're good at. And it's a really bad advice to say follow your passion, because I think that's really a wrong advice. The real advice is to say find out what you're good at, improve on that, capitalize on it, and have an impact on the world. So in short, I'm creating a sort of a new job, which is new job description, I would say, which is called machine teaching. So if you can show a robot how to do one thing once, it can go and repeat it for as many times as you want. So imagine you want to build 100 chairs, for instance, right? And the set of skills are very, very much constant for these, right? So these are the skills which make up a carpenter. And now if you have to build 100 chairs, you basically tell them, you communicate this blueprint of the idea you have about how this chair might look, and then the robot already has the skills, and then it can go and build these 100 chairs. You don't have to really do it yourself. And in some sense, the person who's giving this communicating this blueprint to a robot is actually more productive than doing it manually, because now you can reiterate on ideas much more quickly. You can repurpose the hardware, which is used. You can use the same robot to do something else. If something goes wrong, you can quickly change it, and it comes into reality, right? So the best advice I can give to an ECE grad student is actually not even technical or anything to do with work as such. I think the best thing to do when you get into a PhD program or a master's program is to have a good social life outside of academia, right? Because when you're doing research, you ask anybody, you are not equally productive on all days. And trust me, you would not be productive on a few months in your PhD, and that can happen totally. And in those times, I think it's really important to have like a good social group, and that really helps your mental health. And having friends to fall back on and talk about what's going on in your life outside of academia or within academia, I think it really helps you stay alive in the grudge of PhD. So yeah, have a great social life outside of academia, and that would really help you survive well. The great part about answering this question is almost everybody is free to choose how they carve their lives, right? And I think different people work at different level of optimus. So some people want to come in early, leave early. Some people are late night workers, right? So it's not a typical day that I can say, but what the components are these, right? So at a meta level, you will be thinking about algorithms, implementing them in simulation and in an actual robot, seeing if they work, and if they fail, you change your ideas, you reiterate, and then try them again. So that's like of the meta story of how your life would be. At a more specific level, I think on a day-to-day level, you would probably have a few meetings. Depending on your level of engagement, you will have meetings, and you will be meeting with me, you will be meeting with your coworkers, you'll be taking classes. If you're early on in a PhD and later on you get more into your research, that's where you have more freedom to decide when you want to work. But I think meetings are kind of this one thing which I try to maintain, that it forces everybody to touch base with the rest of the group every now and then. And so yeah, that would be the main components. And and those meetings have to be in times which is at what society works. So it has to be in working hours. But other than that, I think people are free to choose how they work when they work.